All right, so we're doing a continuation of for 3 today. Like a brief recap on what we talked about yesterday. I do want to throw in a couple examples of stuff that you'll see. But yesterday we talked about, obviously, SOHCAHTOA and how you could apply that to any triangle, any right triangle, but specifically how you could tie it into 30, 60, 90, 45, 45, 90 triangles. So we gave an example where if it said like sine of 30 degrees or secant of 30 degrees, whatever it is, you're going to have now 2 choices. One is know your unit circle, pull those x and y coordinates, or the y over x if it was tangent. The other is set up a right triangle with the a as 1, and then it's 35, 40, 35, 30, 60, 90, or 45, 45, 90 triangles. So the relationship between the side lengths on a 30, 60, 90, a generic one, not necessarily a unit circle one, was a root 3, and 2a. So if you got given a right triangle and it said this was 30 degrees and I gave you, let's say this side was 10. The question is, can you fill in the rest of them? And the answer hopefully is yes, okay? If I were to set up the side lengths, that side is opposite my 90-degree angle. This is my 2a. This is my a. This is my a root 3. So if 10 equals 2a, then a is 5, and a root 3 would be 5 root 3. So you would have to be able to know how to fill in the rest of the sides on any 30, 60, 90. If it was 45, 40, and then if it's a unit circle triangle where your a is 1, then this is root 3 and this is 2. And you can use those side lengths to set up your sine, cosine, tangent, secant, cosecant, and cotangent. If it's a 45, 45, 90 triangle or an isosceles right triangle, again, any right isosceles triangle would have the side lengths a, and a root 2. Those would be the ratio of the sides. So if I just gave you one that had the 45, and I told you this was 10, again, if I wanted to find the other side lengths, I'd have to say that 10 equals a root 2, and I'd have to solve for a. So I divide both sides by root 2. I'd get a equals 10 over root 2. That would have to get rationalized to 10 root 2 over 2, which means a is 5 root 2. And that a goes on both the other sides of a 45, 45, 90 triangle. Standardized tests love 45, 45, 90, 30, 60, 90. Like most of them will include something like that. So it's really important you remember those. And then also if it's a unit circle right triangle, your a's are 1s, your hypotenuse is root 2, and you can also use that for your SOHCAHTOA. So the purple example, you could only use this way. It's not like you can use a unit circle if your r is not 1. But the bottom, these, you can either use your right triangles or you can use your unit circle coordinate points. All right, the last thing we'll review before we get back into the finishing is the cofunctions, okay? So remember that cofunctions are really just like either used for replacement, substitution, or they're used with their complements. So a cofunction remember sine goes with cosine. Sine of theta is the same thing as the cosine of 90 minus theta, or its complement. And then the reverse of that, the cosine of theta is equal to the sine of 90 minus theta. Those two go together. Then tangent goes with cotangent, so the tangent of theta is the same thing as the cotangent of 90 minus theta. And the cotangent is the same thing as the tangent of 90 minus theta. Or all of these could be pi's over 2's. And then the last pairing is secant and cosecant. So the secant of theta is equal to the cosecant of 90 minus theta. And the cosecant of theta is equal to the secant of 90 minus theta. So we saw in the notes yesterday that these can be used 2 different ways. One is it will literally say, find the cofunction of the cotangent of 40 degrees. And so you would tell me that's what? Which one goes with cotangent? Tangent. And what's the complement of 40? 50 degrees. So the tan of 50 and the cotangent of 40 are cofunctions, and they will give you the same value. Like if you literally typed it into your calculator, you would get the same value for both of those. Because the opposite... So if you think about it in a triangle, right? 40 and 50 are going to be in opposite angles. So the opposite side of 40 is actually the adjacent side of 50. Correct. And then the other way you saw this is it could literally say like find the sine of 90 minus theta, and it really means find the sine, or find the cosine of theta, right? So we saw that both ways. Questions before we finish it up? Okay, so we ended with the SOHCAHTOA, we did it with a triangle, and then you're going to do it with your word problems. So two of the like kind of terminology that you need to know that most word problems will usually have in there is angle of depression and angle of elevation. And I would say most people don't confuse angle of elevation. Elevation is literally like level up. So if you're on the ground and you're looking up at something, it's from the ground up. If you're standing like on this example, somebody's like on a balcony, the angle of elevation is from their eye level, so straight out, up. Elevation, up, like the elevator that Ryan got stuck in. Okay? Then angle of depression is level down, and that's the one people tend to mess up. They tend to put it here, and it does not go there. It is from horizontal, from wherever you're at or whatever the object is, down. So this angle in here is theta. So if somebody's on a balcony and they're looking down, again, draw out the horizontal line straight from where that person is, and then whatever they're spying on the ground, this case is a car, that creates the angle. If it's like on the edge of a cliff and you're looking down at something, like whatever that is, angle of depression goes straight out, down, okay? So you then can set up a right triangle, obviously the vertical with the horizontal makes your right angle, and then you'll set it up. It'll give you either an angle here or one of the angles on one of the sides, and it will ask you for another side. So you'll use either sine, cosine, or tangent to find it, or it will give you two side lengths, and it will ask you for the angle, and that's when we use the inverse functions, which we'll get to in a little bit. So all that basically just says what I talked about. Horizontal above is the angle of elevation. Horizontal down is the angle of depression. All right, example 7, and these have pictures on them, but there are obviously ones that are in your homework that do not, and your quiz will not. So you've got to be able to set these up. This one says the irregular blue shape is a pond. The distance across the pond A is unknown. Find the distance. To find the distance, a surveyor took the measurement shown in the figure. What's the distance across the pond? So in this example, we're trying to find A. It already drew out the right triangle. So I have an angle this time, which means I'm going to do trig function followed by that angle equals, and then I have to figure out the relationship of the sides to that 24. A is where in respect to the 24? Opposite, and 125 is adjacent. So which trig function uses opposite and adjacent? Tangent. So I do the tan of 24 equals the side opposite, which is A, over the adjacent side, which is 125. If the values in the bottom, these are the easy ones. You literally just multiply. So I'd multiply the tan of 24 times 125. Careful how you type that into your calculator, because you can't do tan of 24 and not close the parentheses and do times 125. So for me, I prefer to just type the 125 in first, and then you don't have to worry about your parentheses. Now, what mode does your calculator have to be in? Degrees. So most of the word problems are in degrees. Make sure you're paying attention, because obviously on the quiz you're going to switch back and forth. So mine's in radians. And when you reset your calculators for Friday's quiz, they will be in radians. So 125 tan 24. A is 55 point. Most of these I think say nearest tenth, so it's 6.5. We're going to say that's 7. And this time we'll have a unit, which is feet. Questions on that one? Okay, and then this one says a building is 21 meters high and it casts a shadow of 25 meters long. So could you draw this without the picture is what you really need to determine. You have a building, it's 21 meters high, and it casts a shadow. So somewhere is your sun, whether it's on that side or that side, you decide. If my sun is here, the shadow is going to be behind the building, and it's 25 meters long. Find the angle of elevation of the sun to the nearest degree. Now, sun is technically over here, so if I wanted to find the angle of elevation, I could put my theta there. But this line is going to continue down, and this angle. All right, that angle, these actually have a relationship if you remember from geometry. Do you remember what it's called when they're in the same spot, if those are parallel lines?
I just know that they're the same value.
They are the same value. If this is your parallel lines and this is your transversal, they're called corresponding angles. So they would both have the same value. So you could put the angle up here and then move it, or just know angle of elevation of the sun goes ground up. Okay, that will always happen. So then this is your angle you're trying to find, that theta. So I've got a right triangle, which is what that picture shows. I've got a right triangle where this time I'm looking for the angle. Do you remember what changes when you're looking for the angle on your calculator? You're using the inverse buttons, which are the ones over what you would normally use. So I still have to set up the relationship. In relationship to this theta, 21 is where? Opposite, 25 is adjacent. So we've got tangent again, but this time it's tangent of an unknown angle equals 21 over 25. So when we are looking for the angle, we hit the negative ones. I do tan negative 1, and I leave that ratio as it is. Tangent negative 1 of 21 divided by 25, and I get theta is 40.03 degrees, or 40 degrees. Most of the word problems, again, will be in degrees. Like if you go on the internet and you search for Right Triangle Trig word problems, some might give you radians, but for the most part in here, your book, all the stuff, the PDF for homework is going to be in degrees. Yeah.
You put the 0.0 there, right?
I mean, technically, no, it's not a significant digit, so you don't need it. I have been told that not that it matters for you guys, but the AP, if you don't put it, it docks you, which is interesting. Yeah, I mean, if they say round, they mean round, whatever it is. But in here, don't worry about it. So again, homework, if you didn't start it yesterday, you've got the web assigned part, and then you've got the PDF of the word problems and the right triangle trig, okay? And then tomorrow we're moving on, but I'll also post the quiz review because this is where the content on the quiz ends. Good news is 4-4 has a little bit extra practice of the trig functions of the angles, which is on your quiz. But your quiz is just covering 4-1, 4-2, and 4-3. 4-1 was all the coterminal. Degrees to radians and radians to degrees, and arc length. Yep. 4-2 was your unit circle, and then using it to find the values around your circle. And these had calculator questions. No, it's 4-1, 4-2, 4-3. 4-3 is what we just finished, the right triangle stuff. I think it's 10 plus your unit circle. Might be 12 plus your unit circle. Yep. So I did unit circles 30 points, and then the others are divided amongst the other ones.